Okay, we're going to start on section 10.5 and we're hopefully going to get this finished today. There's quite a bit in this, but it's a double today, so I'll do at least a couple of videos. So the first part is hypothesis testing, so very similar to section 10.2. Hypothesis testing, remember there was 5 steps: write down null hypothesis, alternative hypothesis, write down the sample proportion, write down the margin of error, do your confidence interval, and then either reject or accept, or reject or do not reject the null hypothesis. And we mentioned there about the level of significance. I know I got asked that before. So it's very similar for hypothesis testing of a population mean. Okay, so use this when you're talking about the mean. I'll just quickly go through this. I'm going to get you to read through this yourselves, and I'll tell you exactly what to do in terms of examples. It says in section 10.2 there was another type of hypothesis testing. It's very similar to 10.2. Okay. And it compares what a 5% level of significance is the same pretty much as a 95% confidence interval. So, looking at that 5% level of significance, now the confidence interval is created from this, okay, that we're looking at 1.96, the magic number. Okay, so when you're doing a hypothesis test, 1.96 is the magic number. Again, we've used that number before. Again, you can read through this, so I won't go through it in the video because I'll just be double wasting your time. So, when a population is very large, it is generally not practical to find the true mean and the standard deviation total population, like we said before. However, assumptions are often made about these values, and their validity is tested based on observations made from random samples taken from the population. Take, for example, machines designed to produce batteries which last for 120 hours with a standard deviation of 4 hours. What conclusions can we come across the machines if a random sample of 50 batteries produced and a mean life of 121 hours? We now begin the process to investigate this, and this is the hypothesis test, like we've done before. So the steps are very similar. First step, write down H0 and H1. So take down that H0, H1. Then, instead of working out the population proportion, what we do is we state the significance level. Okay, and the significance level for our course is 5%, so it's always going to be this. So it's like our confidence interval. If it's less than 1.96 or greater than 1.96, we reject. So the second thing is to write down our significance level is 5%, and Z is less than 1.96 and greater than 1.96. So if it's either of those, we reject the null hypothesis and accept the alternative. Calculate the test statistic. This involves converting the units to Z units, okay, using this formula which we've used now multiple times. I'll show you the information again from the question. And again, this is showing you for a particular, so it's giving you a particular example. Read through, I'll do another example. And then this Z happens to be 1.7767. So this is less than 1.96. So it says, since 1.76 does not lie outside the range, we do not reject the null hypothesis. Okay, so we can't reject it. And then look, it says, if the standard deviation is not given, so if they don't say the standard deviation of the population mean, just use the standard deviation of the sample instead. Again, it's just to give us the best and accurate answer as possible. Okay, so what I'm going to do is I'm going to go through this example in this video, and then in the next videos I'll talk about p-values and the test of significance using the p-value, okay? So, example, it's the example 1, so obviously I've shortened it out, so you can refer back to this if you don't want to write everything. So it says, over the years a market gardener found that the mean yield of his tomato plants was 1.83, so he's pretty much saying that out of his whole yield the mean is 1.83 kilograms, and the standard deviation 0.35. It says 1 year he planted 600, so the sample he's looking at is 600 sample size of a new variety, and those yielded 1.87 kilograms per plant, so a mean of 1.87. At a 5% level of significance, so 5%, sorry you can't see that there, at a 5% level of significance, so again similar to the 95% confidence interval, test whether the mean yield from the new plants is different from the normal variety. So first step, write down the null hypothesis and the alternative hypothesis. So the null hypothesis is the mean, mu, is 1.83, because that's what he states from his crop. And then the alternative hypothesis is just that the mean is not 1.83. That's all you're saying. It's not. You don't know what it is, but you're saying it's not that anyway. Okay. Second thing we do you write down the level of significance, and you literally write this down. The level of significance, and this is the same for all of them, is 5%. And that means critical region, they call it critical region, is Z less than minus 1.96 or Z greater than 1.96. Same every one of these. Okay, so if you're asked to do a hypothesis test for a population mean, not a hypothesis test for a population proportion, but for the population mean, you just write that down as your second point. Third thing, we want to calculate our Z. Don't mind the baby in the background. Right, Z, x bar minus mu all over standard deviation. You should know this formula off by heart now, but again, don't risk it in an exam. Always look up. It's on page 35, I think. Yeah, it's on page 35, remember? Up the top there. Okay, so we're going to fill in this. Equals x bar is 1.87 minus 1.83 all over 0.35 all over the square root of 600, and it's done that in your maths or in your calculators. That should give you 2.797. And then the last step is step 4. You come to your conclusion. Step 4, all you say is since 2.797 is greater than 1.96, we reject the null hypothesis, or H0, and conclude the new variety. Now look, they've put this statement at the end in context. So sometimes they'll say in context of the question. So that instead of saying we accept the null or the alternative hypothesis, they've said the new variety of potatoes is different to the normal variety. And most of the time they'll accept, we reject the null hypothesis but accept the alternative hypothesis. But if they say in context of the question, you have to go back to the question and say, oh, this was about weight of potatoes, and he says the mean of his older crop was 1.83, but this one has yielded outside the critical region, so we say that it must be different to his old variety. Okay, so take that down. Take down the notes on how you do a hypothesis test for the population mean, and I'm going to give you some questions, but we're going to do some more videos as well today. So this will be for the first few questions when you're asked to do a hypothesis test.